You're about to listen to the Complete Developer Podcast, the podcast by coders and for coders about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast. Before we get started, Will, what have you been fighting this week?
Well, not so much fighting as just kind of had a little surprise thing this weekend. There was, my side project. There's a data feed that we didn't think we were going to get, and then we got it, and I had to write an importer for it. I got a little freaked out because the code worked the first time.
Oh, that is scary.
And it's like you kind of learn that your code kind of stinks. Everybody's does at some level. And so when stuff just works out smooth, you immediately mistrust it. And that's the engineering mindset. It's like, okay, this is going well. What's wrong?
Yeah, it's like, have you seen that meme with Fry from Futurama? And he's got that pensive look going, don't know if I'm a genius or if my code is just going to blow up.
Yeah, it was pretty solid. And then I did find there turned out to be actually one little bug, because it was a UTC timestamp or something, but it was strangely effective. It's like, okay, and we're done.
Wow.
Weird. And yeah, so that threw me a little bit. And I've had that happen 2 or 3 times in the last, few days. Where everything fires on all cylinders. And, I have that pessimistic engineering mindset of, okay, what's going to go wrong? Because something is, and then I don't find it, and I don't handle it well. So yeah, that's basically been it. I've been kind of going into a process of starting to do a monthly review. So at the first of the month, I kind of write a note in Evernote talking about what happened over the last month and how I felt about everything going on, so that I've actually got a record going back into the past.
You post these for us to all read?
No. There's, besides the fact that we have a G-rated audience, and this is not remotely close to that, because I say exactly what I think about various things. But it's a lot of personal. It's more a thing of, I can go back and look at, what my mental state was and how I was reacting to things, with the hope being that at some point in the future, when I'm doing something more difficult and I remember things that worked well in the past, if I remember, hey, it kind of sucked around February, right as that was going on, I can go back and look at those notes and go, oh yeah, I was feeling then the way I feel now, and it worked out. Yeah,
I can see that. That's a good idea.
That, and sometimes getting it on, getting it actually typed out, you type stuff and then you look at it and you're like, that's accurate, but I never really, it just kind of comes out automatic. So I'm playing around with that.
You got a bit of catharsis in there.
Yeah. Well, and it's not unmanly because it's not a diary. I guess. I don't know. I'm gonna play with it though. It seems like a good idea, and I learned that from the folks at Zen Founder. They kind of talk about, I forget who she had on that was discussing that, but they laid that out, and then when they're coming back years later, they can see the growth and they can see the progression, and they can go, hey, every time I do these certain things, I'm ticked off for a month, or I'm happy. And, you can kind of actually plot trend lines versus your euphoric recall of the past. We'll see how it goes. So how about you?
Well, finally finished the Hexo theme I've been working on for you.
All 5 of them?
It wasn't 5 themes. It was 5 different layouts of the same theme. Yeah, it was basically just, I thought of different ways of putting together the front page for you based on the things that you had said that you wanted.
Yeah, and for those out there that don't know what's going on, I have a WordPress site for Gantt software systems, and it's constantly getting hit with, people trying to break into WordPress. There's all the WordPress updates. I'm jittery that I'm going to lose everything and not be able to recover it. I don't have a good testing environment. So I'm not going to roll out any changes because I can't test them.
Yeah.
And I finally started realizing earlier this year that I'm like, wow, I just really hate the WordPress ecosystem for what I'm trying to do. And I really just need a static site just about, because that gets rid of 99% of my problems. And so I was building the site in Hexo, and then I get to the point where I'm like, oh, I need to lay out a theme. And I fiddle with it and I can do it. But then I'm like, this is stupid. I've got a task list. I mean, like after you leave here tonight when we're recording, I have like 8 items to do.
Yeah, I understand.
So then they're not going to get done. Like 1 or 2 might, but probably none of them. Realistically, we've got pretty good beer. And so I was like, well, Beej is trying to move up the development curve and, get some stuff to show. He's going to be building themes and things for other people. And it's like, why am I doing this myself when I could pay him to do it? It helps him. It helps me because it gets it off of my list. And, I don't have to be sitting there agonizing over whether to use Bootstrap or not with a theme when it's really not something I'm going to be messing with.
I did use Bootstrap with your theme.
Yeah. Well, I figured you probably did. But, the thing is like, I know at a certain level, you get to the point where you've done enough stuff that you stop being able to do things effectively because you sit there and analyze. It's like, no, I need to get a website up. That, like, full stop. Not, I need, it needs to be this and this and this, or otherwise, somehow I'm not going to be seen as tech savvy if somebody looks at it. I realized I was getting that mental block. Mm-hmm. That, and I was chewing up a lot of time. I'm like, this is just idiotic. I'm not functioning appropriately, so I need to do something different. So that's where you came in.
Actually, it's been great for me because I've really, over the last kind of week and a half that I've been working on it, I've really learned a lot about Node and Hexo. I even spent some time when I was working on trying to figure out how to do a contact form with Angular material design, mm-hmm. which I kind of like that, but
yeah. See, I didn't think through the only thing was the contact form, and something that might work is Google Forms. Can't you embed those in sites?
Yeah, I hadn't thought about doing it like that.
That's a wacko idea that we'll try.
Yeah,
because that could actually work out stupidly well.
Well, I was going to say what I ended up doing was I found a third party that is specifically set up for static sites to do contact forms.
Yeah, I'm glad you found helpful people in the Hexo forums that suggested that.
That's the other. So this morning, I wake up and I have a text on my phone. And I look at it, and it's from Will, and it says, that moment you realize that you've replied to a person on a Hexo forum, and you realize who it is, or, well, how did you put it?
Something to the effect of, I realized after the fact, because what happened was, basically the way it worked out is I was pre-caffeinated, and it's like first thing in the morning. I woke up a little bit early because I went to bed a little bit early last night, and I had like 25 minutes where it was just, I don't know what I'm going to do with this time. And so I come downstairs and I'm messing around, and I see the group summary from the Hexo Google group. Yeah. And I said one thing, I'm like, hey, I can answer that question. Might as well. And then I answer it, and I get all the way to work. And then I go, wait a minute. And something clicked in my head, and I'll go back and I look at it, and I'm like, I just answered Beach's question. Why is he in here? Do they not have standards? Well, of course, I wouldn't be in there either if they did. So, yeah, that was just kind of surreal.
It was kind of reminiscent of college back when we used to be on some of the same email groups.
Yeah.
Back when email groups were a thing.
Yeah, I kind of still wish they were. I hate how everything's on Facebook now.
Yeah, I'm not the biggest fan because it's gone from, with email groups, it used to be, and this is me just being old, but it used to be people thought out their posts, and when it was almost like a blog post responding to a blog post, and there were real...
But it really wasn't that intelligent. I mean, if you look back to, I don't know, Legend of the Blood Ninja, okay, if you're under 18, please don't look that up. Actually, just please don't look that up. Just in general. like there was a lot of trolling even back in the day, but we have a bit of a euphoric recall. But like,
I'm not saying there wasn't trolling. What I'm saying is that the legitimate posts were not just like memes and pictures and 140 characters. They were actually thought out, written out posts.
Well, and the other thing I find too with Facebook is increasingly it's not that I'm trying to share information with people, it's I'm trying to keep information from people. Mm-hmm. And Facebook doesn't have a really good model for that. In fact, we should do a breakdown sometime of why Facebook's social model is not a good real world model. In other words, a bad abstraction.
Oh, that's a good idea. I just hope we don't get sued. I'm kidding.
I hope we don't get hired. So anyway, it's about time to face that music.
It sure is.
Actually, we're not facing the music anymore. We actually like the music, but
yeah, good, because you say face the music, I think face the Raven. Little Doctor Who reference out there for you guys that are Doctor Who fans. Anyways, let's roll that glorious music. This week for IoTs, we're continuing along with our Marches for Makers, and I have something that's kind of a project that you can do with the kids. This is really neat, and I've already talked to my nieces, and when they come up and visit this summer, we're going to build this. It is called the Bloop Bubble Notifier. So instead of being notified via sound, light, or vibration, you can get notified by a bubble in liquid. And it's kind of a neat little project that builds some networking, some software skills, and uses something that Will and I used when we first started the podcast. And I even wrote a blog post about it, and that's IFTTT.
Okay.
Yeah, that's how you get your notifications. The instructions are phenomenal. Of course, that will be in the show notes. Now, in some of the other IoTs this month, I have read off the hardware. This one's a bit long, about 24 different things on here, so I'm not going to go through every little piece, but it will be listed in the show notes with links for the ones that had links provided. The software is basically the Adafruit IO, IFTTT, which has an Adafruit, well, not really plugins, they're just component to it, I guess. And then, since you'll be using an Arduino, the Arduino IDE. And it's just, like I said, it's a really neat, fun project that, with some adult supervision, kids as young as 5 could really get into it.
So baby's first soldering iron?
Yeah, something like that.
Christy, I say that as a, 36-year-old who burns himself every time he tries to solder something. I swear, it's just, I really wish that was a skill that I have, but I guess...
How often do you solder?
Not often enough. That's the deal. I've got it actually right behind you. There's a practice board. I think that's a practice board kit for that, so that I can get where I'm not terrible at it.
Yeah, you do.
So yeah, you and I ought to do some hardware projects. Maybe once you get moved up here.
Yeah, I do plenty on my own.
Yeah,
I've gotten pretty good at soldering.
We'll come up with something stupid to do and just go do it.
And then we'll talk about it for an IoTs project.
Might as well.
Yeah.
So this week we're going to talk about how to identify areas where there's technical debt in your project.
I know we kind of mentioned this last week when we were talking about refactoring.
Yeah, and we brought up technical debt before. I'll first read you the Wikipedia definition, which, as you know, I'm not fond of most definitions that I read because I find that they tend not to be very expressive about what's actually going on. But the Wikipedia definition is that technical debt, which is also known as design debt or code debt, is a metaphor, which I agree with, referring to the eventual consequences of any system design, software architecture, or software development within a code base.
Now, I do remember when we were talking about feature toggles a couple of weeks ago, at one point you said that that was the true definition of technical debt. So I guess why do you take issue with the term?
Well, for several reasons. Do you have any debt personally?
I have debt?
Yeah, I know you have debt. That's more American than apple pie.
Which this beer I'm drinking tastes like apple pie.
Yeah. Well, the point of debt, if I go to a banker and I say, I'd like to borrow some money, what are they going to say?
What can you put up in collateral?
Well, they're going to talk about what you can put up in collateral. What else are they going to talk about? Like if you're going, hey, I want to take out a large debt, not, $500, but I want to take out a debt for $150,000.
They're going to tell you that
$500,000.
That banks don't do personal loans anymore.
Well, what else they'll tell you?
What's that?
Or they'll ask you, what do you intend to do with it? That tends to be the question because they want to know that you can service the debt. Right? There's an economic incentive because if you go bankrupt because, hey, I spent I borrowed $500,000, I went to Vegas and, I lost it all. Banks don't like that.
Would you?
No. I mean, it's completely rational, right?
Yeah.
But we refer to technical debt and we call it that. Sometimes it is actually technical debt. Like it's something I built this thing and I did a kind of hacky design decision so that I can get a product to market and get out ahead, or so that I can get something to show to a client. Mm-hmm. But I'm coming back later and I'm going to fix it. Like I'm going to pay the debt. A good, at least 50% of the time in the tech world, when they say technical debt, what they really mean is you borrowed $500,000 to fund a house party for a certain Hollywood celebrity that we won't name, like any of them. I just don't want to get sued. Right?
Yeah.
Like there's no money coming back in from this. It's just ostentatious, ridiculous expense. And that's what a lot of it kind of is. A lot of it too is stuff. It's sort of like accumulated credit card debt for groceries. It's that sort of stuff. It's non-productive debt. And so I have a problem with the term, for one, because what's the collateral? That's the other thing too, is like, it's a metaphor, but it has a lot of holes in it.
It's a poor metaphor.
Yeah. It's okay to look at it in a financial sense, but it's more like selling an option to something, or, like there's an
unhedged call option.
Yeah. I think we actually discussed this at some point.
Yeah, you gave a really great definition.
Yeah, and it's one of those kind of things like where there's an outsized risk that's going to hit you at some point that you don't control. Debt typically doesn't do that, right? There's a payment schedule. Yes. And the idea is to, whoever loaned you the money wants it paid off. Well, so this isn't very good as a metaphor.
Basically, when most people refer to technical debt, it's not, I took this out with the intent of paying it back.
Yeah, I took this out with the intent that somebody else will hold the bag.
Yeah.
Or I took this out with the intent, it's sort of like people that, if you've ever, and there's plenty of stories going around where people have found out that they had some incurable disease and they didn't find it out from a doctor. They they found a lump or something like that, and they go and they borrow a bunch of money and then they live extravagantly and then they die and, the money's gone. Right. Somebody else is holding the bag. Like you're not going, okay, I'm going to take care of this problem.
Kind of like in the movie Armageddon, where the guy goes and, takes out all the big loan from the loan shark like a week before they fly out into space because he doesn't expect to come back alive.
Yeah. It's that kind of maneuver. So we're calling it technical debt, but understand that I have problems with the metaphor from the beginning. But we'll discuss, these are basically design problems and how to find those. So there's several kinds of cues, and we're going to go over these. One of them is social cues, another is code cues, and the final one is testing and deployment cues that tell you where you have technical debt. So social cues, and these are actually some of the easiest ones to pick up on. Bear in mind, I've spent a lot of time refactoring code, and so
honestly, from a social cue standpoint, developers are people, and we don't like dealing with certain parts of code.
Yeah, well, and bad code can hide, but reactions to bad code doesn't hide as well. Right?
Yes, that makes sense.
Particularly among a set of people who tend to pick working with machines versus working with people. It's a lot more obvious where there's a problem, because you'll see developers that they don't like dealing with certain parts of the application because, it's a mess. It's like, I have to go into this stupid, when they start muttering and stuff, that's typically a clue that there's some significant technical debt there. Mm-hmm. And this person is essentially saying, hey, I don't want to pay off my kid's car loan, or I don't want to pay off my car loan. It's an indication that there's a problem, because if it's a happy, fun part of the code, people are like, oh yeah, sure, I'll jump in there and fix it. But if it's something that's awful and they know they're going to be pulling their hair out, they're going to start complaining. And you'll see that before you see the problems in the code. Yeah,
because the problems in the code don't speak, and they may not make it non-functional.
Yes. Because I've written some pretty terrible code in my career that has been perfectly functional. And I mean, like, going back on it, everybody has files that they look at and they're like, oh, that's awful, but it ran.
I don't know what you're talking about. I've never written bad code.
Yeah, right. If you haven't made any bad decisions, you haven't lived. One thing is they don't like getting in there and dealing with that part of the system. Mm-hmm. Another place you'll see it is where they don't like interacting with it. So instead of, I don't want to go into this code, I don't want my code to call this code either, right? Because
they still have to.
They're still technically dealing with it, but they even have less control. They get louder on this one, because if the code is garbage and it, dumps out weird outputs and stuff. I mean, I've seen payment processor code where you've got, 3 or 4 payment processors, and this guy decides that, this one doesn't work the way I like, want it to be. And so he changes it, but it's in base class for all those 3, and it breaks the other 2, and he doesn't fix it. And everybody hates his base class code because they have to interact with it and try to hack around it. And he who shall not be named actually had to recently deal with a lot of this, and I think it's still an item on his plate as of this recording. And it's not that he's having to go into that code; it's that stuff he's building has to work with it, and it screws up things he's doing, and so he's having to build technical debt into his stuff because of this other debt.
It's almost like a snowball effect.
It is. It's exactly like that, right? I mean, you have the phenomenon where people that are impoverished, right? They can't get out of it because you're too broke to have a buffer. Yeah. And what happens? Well, you take out a payday loan because you want to eat, or your kids need to eat, and now you have even more debt that you can't pay off. And so, in that sense, the metaphor works. It's just that the risk is actually a bit more outsized. It's like, you have an alcohol problem and you're broke. Another social cue is when end users are complaining about that part of the system, like it breaks frequently or it does weird things. So, sometimes it screws up data. Sometimes it does odd stuff that tends to indicate technical debt. One place where I see this a lot is where you have multiple tables being written to by some operation. And it's like, most of the time it works, but sometimes, it's got the parent record and no child records. Because, some goober wrote it to where those are being written to in separate transactions, and the second one failed. And the code is so nasty that nobody caught that and was able to fix it. Like, you'll see that sort of social cue because, again, it's hard to objectively judge code because everybody's, if you see good code written by somebody else, you're probably still going to hate it at some level because it's not yours. But the way to actually see it is the social interactions around that code. A lot of times will give a shape to it. It's like a magnetic field. You don't see a magnetic field. You see the iron filings the way they lay out. So it's that.
Or the wind. No, that makes sense. I'm kind of getting from this that this is something that when you're trying to get an estimate of the amount of time or effort, areas with a lot of technical debt that developers and even their managers are not going to be able to make easy estimates on how much effort or how much time would be required to change that part of the system.
Yeah, because everything they touch, something goes wrong. Or, there's 4 other things they have to deal with. I mean, we talked about that with, tight coupling of components. That's what I was dealing with the web pages, is that it's like, okay, I can do this one thing and this is easy, but to do it, there's 15 other things that are not. And they're completely arbitrary. They're not there because of the actual problem space being solved. They're there because the code's crap.
One of the places that I have recently been interviewing uses Scrum. Having not done that before, I've been doing a lot of research on it, hopefully, because I really do like this particular place, and I'm hoping that it works out between me and them. But anyways, I've been studying up on it, and part of that is doing coding sprints and predicting how much effort is going to go into a particular part of that sprint. And so I guess that's why it's just kind of coming together for me on the whole social cues. Yeah. Is I can see, because I've interviewed with the team, I think I talked about it. It was supposed to be a 30-minute interview and it went over.
Yeah. And project managers and managers in general do not like wide swings in unpredictability. They like predictability within a tolerance, but when it's way out there and you can't actually make a good decision because you don't have the data, they get frustrated. And that tends to be a sign that, hey, there's something wrong with this area of the code, that we need to get this where it's predictable.
Yeah. Well, it's like the Scrum Master in the interview, he and I were talking, I was asking some questions, and he was explaining that basically his job is to take the 2-week time frame that they do the sprint and then take the estimates from the developers on how long it'll take to do each bit and plug that into each sprint.
Yeah, and figure out his burn down. That way, when you're halfway through the sprint, you can tell it's like, okay, are we on track?
Yeah.
To get to the end. Well, what happens when it's, this is going to take X hours, this is going to take Y hours, and this is going to take null. Because literally you don't know. Well, what happens? Well, if you look at programmatic systems, they go either this is an error or it's null, because I don't know about any of it because there's a null in there. Yeah. That's effectively the problem they're dealing with.
That's a good way to put that.
Yeah. I mean, somebody told me that at some point, and it'll probably come back to me who it was after I record. But
I'll be honest with you. I quote you a lot because I know my source of many things that I quote, because you're pretty much the only you and he who shall not be named are my 2 major sources of senior developer
crankiness. And
yeah, that's a good way to put it.
Yeah.
Because I know it's either coming from you or it's coming from him, and your language structures are just different enough that I can tell when I'm quoting who I'm quoting.
Yeah. Now, in addition to the social cues, you will see the code cues. These are a little bit harder to see. You have to get down in there. It's not something as quick as human interaction, because you can tell when somebody's ticked off in like 2 seconds or less. Whereas a coding problem takes a little bit longer. But these are kind of referred to as code smells. I think that's in the Pragmatic Programmer, which I believe you got for your birthday.
Yes, and I haven't read that part yet, but I have seen.
Well, it may be in there. It may be in. It was in one of the books that Joe Audette, who was my first kind of mentor. But anyway, so your different code smells that you'll start to see, and you start to get a sense for these after a while. Like it's not something that's obvious.
So you get like a sense of smell for them?
Yeah, you kind of do. You I don't know. You get like an intuition where you're like, okay, I see this, so that makes me know that this is over here.
Well, that makes perfect sense. It's like we were talking before about. It was a few weeks back when I said something to the effect of, whenever I have to repeat code, I automatically pull it out, abstract it out. And you say you usually wait till the 3rd time you have to repeat it. And the reason that I do it at the second time, or the first repeat, is because I'm trying to train myself to recognize that before I have to repeat it.
Yeah.
I've seen you code an abstraction knowing that you're going to use that again. So you abstract it out at the beginning because you had that sense of, I know this is going to be used multiple times.
Yeah, and you get an intuition for it. But the first one of these is when you start to see overly tight coupling to other parts of the system. You're familiar with the concept of coupling, right?
Yes.
It's where if you have a function or an object or some piece of the system, whatever scale you want, because it could be all the way up to the service level or whatever, that is too tightly tied in with another piece, In other words, okay, if I change this, it's going to break this other piece over here. And if I change it, it'll break back. Where they're both talking, they're enmeshed a little bit too much. That's one thing you'll see. But one thing here with these is these tend to be very subjective because people have a varying level of tolerance for that. Because I've also seen people they'll put so many abstractions in between that you can't ever tell what's going on anyway. And their tolerance is lower than mine. They're also less productive. But we'll never get we won't get into that. The second code cue, and I apologize in advance for any offense that this causes, is the term God objects.
Yeah, I saw this in the outline, and this is a term I have not heard. So
you typically see this. You'll see it with functions too, but it tends to be a thing of object-oriented programming. It's where you have an object that does everything. It's everything but the kitchen sink. It's got so many intertangled pieces of, it's basically like somebody took an old BASIC program and said, hey, let's shove every function in the system in this object, basically. And so that, among the other objects, this object is, Zeus or something. It's just, it stands out because it's, 15,000 lines of code, and every other object is like 12 lines of code. Because it's got too much stuff in it.
Well, we talked about this last week when we talked about refactoring, where, you have something that controls everything or way too much and you need to break it down.
Yeah. And you'll get this even at the, at the functional level. Like if you get functions that are way too long, it's that same principle. You get something that's doing too much stuff because it tends to not do any of it very well.
Yeah, that makes sense.
Another code cue is incoherence between components. And that is, I'm trying to think of the best way to put that. It's where, component A has part of the responsibility, component B has another part of the responsibility, but they're both tied together. And basically what the problem is that now it's really a coupling problem. But what ends up happening is they vary independently. And so one of them kind of does the thing that it used to do, but doesn't quite do it right anymore. And so you start to almost have a branching effect. It's one of those things that's kind of hard to explain. It's very, very similar to overly tight coupling. Another thing that you'll see is inconsistent implementation patterns. One of these is there's the big ball of mud. There's the lava flow pattern. Basically, the idea is okay, somebody did it this way. Then the new guy came in and said, this isn't going to happen anymore. We're going to do it this way. Then he left, and some gal came in and did it this other way, and so on. And so there's like 4 different ways of doing stuff. I've worked on apps that have had they've had classic ADO.NET linked to SQL, Entity Framework, and in Hibernate in different parts of the system. You talk about awful, because it's like, okay, well, I've got to talk to the database. Well, how am I going to do it? Well, this one piece over here uses ADO.NET. This piece over here uses Entity Framework. Guess what? They don't share the transaction. There's no way to ensure transactional integrity without a whole lot of pain.
That's
like
missing the entire point of the ORM.
It's missing the entire point of object-oriented programming, but this is something that occurs organically over time.
Yeah.
Because you have different people come in, or, you have one person that can't make up their mind. And instead of going back and fixing the old code, they just leave it and go, okay, well, from this point on, we're going to do this. And which is okay, as long as you eventually choke out the other stuff. Where this goes wrong is that third iteration where you go, okay, well, from that point we did this, but now we're going to do this, and we're not going to fix the first one either.
I've seen this in physical filing format.
Yeah. Like medical filing, especially?
Somewhat medical filing. When I was in grad school, I did my graduate practicum at a doctor's office that we did primarily psychological testing. He had 2 or 3 students every semester, mostly PhD students, and occasionally the master's level student like I was. And each student that came in filed differently, which was fine for things like assessments of 911 responders. When someone was applying to work as a dispatcher or answer the phone when you called 911, they had to go through a psych assessment.
Yeah.
Everyone that does that had to go through an assessment. We did those assessments.
Don't you want those people to crack under pressure? Isn't that a good plan?
Well, we did those assessments, and that was a one-time thing.
Yeah. And let me guess what happened. Over time, the way those things got filed, the way they even got done, Those assessments even changed over time.
Those didn't change. The way the assessment was done didn't change much because that was a state thing, and you know how working for the government is. They don't change easy. But the way they were filed in our system did. We also did a lot of testing for various doctors at the particular hospital that we worked within their group. I'm specifically not naming names because...
Anyways, hospital code is a mess anyway.
Yeah. But we would see a patient once, maybe twice, and then we would file it, and it may be 2 or 3 years before their psychiatrist needs them to be retested.
Yeah, and then you got to go back and try to find their record, and there's 4 different systems you have to look in. This is sort of that class of problem.
Yeah, and I had an issue where I ended up getting to the office about 30 to 45 minutes early every day because of traffic flow. And I ended up reorganizing the entire system because what happened is...
And you did it a piece at a time, sort of like we discussed in the refactoring episode.
Exactly!
It's that same mindset. Like most problems that are in programming are actually problems that you have elsewhere. Most of them are actually social problems, not programming problems, because the programming is really not the hard part. I know that a lot of people really take a whole lot of pride in it and go, oh, you must be really smart because you're a programmer. It's like you can give instructions to an idiot. It's the social awareness. It's the organizational awareness. That's what makes the difference.
That's funny. One of the places I was interviewing, a lady was sitting in the lobby with me, and she was there interviewing for a completely different function at the company, and we got to talking. She asked what I was interviewing for, and I told her, she's like, oh, you're way smarter than me. And I'm like, not really. I mean, I have the right type of mindset for coding.
Yeah.
I told her, I was like, it's like working in psych. You have to have a particular mindset. It's not that you're so much smarter than everybody else. It's you can put up with the issues that
you can deal with the particular problems.
Yes.
And but the social, all these things are really... They're really organizational problems. The fact that this occurs is a problem, is an organizational issue. I wouldn't say it's a problem because it occurs organically. Getting back on point, another code queue for technical debt is dead code. And this is code that's not being called. Now, you'll notice in parentheses I said, or undead code, as it were.
Blah, blah, blah.
No, don't do the Nosferatu thing.
It wasn't Nosferatu. It was from Hotel Transylvania 2.
Okay, then. Aren't we proud of ourselves? Dead code is a big problem, and you'll see this a lot when you do have technical debt. When it's really bad, though, is what I like to call undead code, and that's where it's code that you think is probably dead, but you don't know.
Yeah, okay. I see where you're going with that.
Yeah, or it's code that's dead that doesn't know it's dead. And that can be some of the worst to mess with, especially if you don't have good tools to determine, hey, this is being used. In compiled languages, you don't have as much of a problem with this, right? But you do if, let's say it's a library that's used in other places in the organization or outside your organization. You have a public method in that library. Guess what? It's forever. It can't die because somebody's depending on that thing to work, potentially, or someone might.
Unless you're Microsoft, and then...
yeah, but you have no way of knowing for sure that that's not used. So you tend to get a lot of that stuff, and you'll see it over time. Some of your tools will warn you, depending on how good they are. It's like, hey, look, this isn't getting used, but they don't do it if it's something public. If it's outward facing. The worst offender for this, for me at least, is actually typically not in C# code. The worst offender that I see is SQL. There's a stored proc sitting out there. Who uses it? How do you know? Well, there's nothing linking to it. There's stuff in the database, but I don't know that there's some app that was written 15 years ago. I mean, this stored proc has a cursor in it, so it's old school. Who calls it? Well, I don't know. I've got to go in and I've got to poke at the performance data and go, okay, well, is anybody using this thing? How do I tell? Because, bear in mind, it's not a statement of someone is using it. It's a statement of no one is using it. Maybe it only runs on February 29th.
We had one of those this year.
Yeah, well, and stuff breaks on February 29th every so often because of this kind of thing, because somebody will remove something and they removed it 3 years ago. And, now it breaks. Well, you have a long distance between cause and effect.
3 years is a long time in tech, and they may not be even at that company anymore.
Well, think about this. What happens if they wrote it and let's say they removed it in 1997? I think let's see, I'm trying to remember the whole rules for leap years, because around centuries it's different. So it could have been 8 years. Mm-hmm. You know, there's some significant problems, and you'll see that, like, it's very hard to make a statement that this is never used. It's easy to make a statement that this is used. It's sort of
sounds like logic.
It sounds like what we did to Saddam Hussein. Prove that you don't have chemical weapons. How does he even prove that? Because there could always be one more place that you never looked. And it's sort of that problem. You can't prove a negative.
Yeah, like I said, logic.
Yeah. Another thing that you'll see a lot of is copy and paste code. This is what I've been dealing with a lot at work. Somebody will see a piece of code and go, okay, I'm going to use this over here, but instead of refactoring and cleaning it up and going, okay, I'm going to call it from 2 places, they just go, I'm just going to move it. And the old code is still there. The new code is still over here, but now they're varying separately.
Yeah, so instead of refactoring and having that code in one place and both call it, and when you have to make changes, you know that it's going out to both places. You copied it over, and
you did the quick thing so that you don't have to test.
Yeah, and I can see that, because as each iteration of changes is made, changes might be made to the old code, but not to the new code.
Right.
Because that's what needed to be adjusted or fixed, and vice versa.
Yeah, and that's what I'm dealing with at work. The other thing you'll see is, like, you'll see it, and there'll be something in the code where you go, this doesn't look quite right. I promise you, do a Google search for that code, you'll find a Stack Overflow article.
Or an MSDN article.
Or MSDN. Oh, yeah, MSDN. Like, they were horrendous for a long time about writing code that proves the concept, but leaks memory, leaks DB connections, leaks graphics handles.
About this because the purpose for the MSDN code
is to show the point.
Is to show that one specific thing. And you even said it. You said people that copy and paste MSDN code obviously didn't read the article.
Yeah. And, that's all over the code base. It's all over a lot of code bases I've seen. I mean, It's kind of endemic in this, this environment. But you'll see a lot of that. And so when you start seeing the same code multiple places, or you start seeing stuff that you're like, this doesn't look like the rest of this dude's code, it's probably because dude copied it. And I'm saying dude in a gender neutral way, I guess.
Finally, we have testing or deployment queues for technical debt.
Yeah, and these are things that you tend to see at the point where you have QA getting in there, or at the point of deployment. And the reason I bundled these together is because you should be rolling it up to hand off to QA, because they also have to test the setup. The concepts get intertangled to the point where it's like, hey, this is kind of one thing. The first one is when you have a lot of friction setting up a deployment and testing environment. This tends to indicate that there's code smells. So, they have to know that, okay, these 17 components get installed in this order, and then you've got to run this script, and then you install component 18, uninstall component 1, and, reinstall component 2, then put component 1 back on there. When they've got that sort of thing, that tends to be an indicator that, okay, there's something weird going on with the code base, and it is costing us.
Speaking of code smells, I looked up where it originated. The term was coined by Kent Beck on Ward's Wiki in the late 1990s. But the usage of the term didn't really catch on until it was featured in Refactoring, Improving the Design of Existing Code.
That book is on my bookshelf, I think. Although,
I've seen it.
Yeah. That actually belongs to my friend Joe Kowalski, who was my boss at a previous employer, and he who shall not be named also worked there after me. I keep meaning to return that book, although I don't know that he cares at this point, because that was like 2006. I might just buy him a new copy of it at this point. Yeah. Another thing that will come out in testing is when testing fails due to brittleness. So, like, if they run their automated tests, for instance, and the first time through it works, and then the second time through it doesn't, that can often be an indicator that there's a problem with the system. It's inconsistent behavior. Typically, there will be some technical debt up under that. Another issue that occurs is the inability to simulate failure conditions. If you can't say, okay, well, what happens if this API is unavailable? Your app is too tightly coupled to some other internal API to the point where you can't fake that it's down, or you can't fake it, period. That tends to indicate that there's something wrong that you need to pull apart and make that where that can happen. So these are sort of like the social cues. They aren't the thing, but they show that the thing is there.
Gotcha. That makes sense. It's kind of like it's
an after effect to look for. Like if you see a bunch of buildings that have fallen down, you know there's probably an earthquake or a NATO hit them. But it's one of the two.
Yeah.
Right? Like they don't just go, "Oh, hey, I'm going to fall over today." That's not something buildings do. So when you see that, something happened. It's sort of that cause and effect thing.
So you got to play a little Sherlock. That makes sense.
Yeah. Well, it's just, when this happens, this probably preceded it. Doesn't mean it necessarily did, because it could also be that the system is just complex. And that's true for any of these things, honestly.
Yeah. We're dealing in generalities here and in what is the most likely cause or what the most likely symptoms are.
And a lot of these things don't apply for systems programming either. Like if you're doing stuff at the level of writing assembler code, or, you're writing a device driver for a video card, that's a whole other can of worms because you have so many performance considerations. It's the same deal with, heavy security code, that kind of stuff. Like, okay, sometimes code is just awful to deal with because there's no way to do it that isn't awful.
It reminds me of an interesting conversation I had with my mother recently. I was telling her about something. I don't remember exactly what led to the conversation, but she asked the difference, like what high level and low level coding languages, what does that mean? Oh, I know what it was now. She remembers that I had taken C++ courses in high school. And so she asked me the difference between that and C#, what I'm doing now. And I said, well, C++ is a little bit more of a lower level language. And she's like, well, what does that mean? And
closer to the metal.
Yeah. And I found it easiest to explain it to her by explaining kind of what assembler is and then what each level of higher language does.
Yeah. And so a lot of these things don't apply. They apply less the further down you go in the code because there's constraints. I mean, at some point, you got to deal with the fact that something has to get done in this amount of time, and there's just no way to do it cleanly in that amount of time. Like if you really get to like systems level programming, it's just going to be ugly in some cases, just because physics hurts. Another thing that'll show up in testing and deployment is the inability to alter configuration for different deployment scenarios. The reason this becomes an issue is like if you got stuff hard coded, like you have to recompile to run it in a different scenario, that causes a lot of pain for the testers. It also means that your code is probably way too tightly coupled, because why can't you pull that out into a config? Well, because it's hard coded in 38 places and I have to change all of those. I mean, I've seen some stuff. Especially, it's not as bad now, but back in the old days, I can remember one app I worked on. It was a good app. I mean, it ran great for the clients, but it dealt with real estate data. Back then, what he had some copy paste code, and there was a form for each county in the state, a separate form. This is VB days. Like this is old school. And I think he compiled it based off of which county it was for. That's painful configuration. Now, that code, it's not because he was a bad coder. It's that code grew organically. He started out with one county, and then he had to add another one that had slightly different requirements. And then he had that explosive growth curve, and it was just like, I got to get this out. And he ends up with debt, effectively. He was doing that for growth reasons. He wasn't doing it because he was sloppy. But all of a sudden, one day you look back, and it's like, oh, we have 68 different forms here. What happened? And so you'll see that a lot, and it's where if you can't alter configuration and change the deployment scenario, a lot of times if you follow that rat hole down far enough, you'll find something like that. And the last one is difficulty in automation of deployment scripts. It's like if you can't script it off because it requires too much human interaction, that tends to indicate that there's something going on there that you need to look at. It's one of those things like you're automating stuff, but then you're having to rely on a human being to get that one little piece over the hill. That tends to be an indicator that something's maybe just a little bit off. And I'm trying to think of a good example. One thing can be just where you've got components that are interacting badly, like they got to be installed in a certain order. Like the first one writes a registry key that the second one has to have to complete the install, but the second one's install will still run all the way to the end without any problem. but it doesn't write to this key, and there's a third component over here that needs that key set the way the second one overwrites it if it sees it. When you have that kind of stuff going on where it's like, okay, we've got to do these things in this very specific order, and it's hard to script, like it's hard to get your head around the script, that tends to indicate that there's something else going on that you have to deal with. It can also indicate that you have a lot of programs. Where I work, we actually have, I don't know, we've got dozens of little programs that have to run. They've all got their own little pieces. Now, we've got a lot of shared configuration, and they've been kind of moving in that direction, but deployment scripts are a pain. One thing that the app has developed over years and years. At some point, there's institutional knowledge there that you've got to figure out how to even get that into deployment scripts. But, when there's a lot of difficulty, especially when it's not stuff that's a little closer to the wire. Like, we've got a lot of stuff that's low level. You guys have... It's graphics rendering.
Yeah, I was going to say, you guys have Delphi programmers.
Yeah,
there.
And, there's a lot of things that you can't tighten up. If you tighten it up for the programmers, you loosen it for the computer. So, we kind of have a unique deployment scenario, but typical shops, if it's hard to script that off, that tends to indicate either tight coupling between components. It tends to indicate copy-paste code. So that's something to look at.
Yeah, and that kind of that hits all the points that we had. Just quick review. We started off talking about what is technical debt. I know Will read us the Wikipedia definition, and then went into a pretty good explanation of why he doesn't like the term.
Like I said, it's a metaphor. It works where it works. I find a lot of people, too, that I know that use that term a lot. They're in a lot of real debt themselves, and they aren't able to get out of that. And so it's very difficult listening to them talk about, here's how you get rid of your technical debt, when it's like, okay, but you've got massive credit card debt. It's like, maybe you ought to use a different metaphor so that you seem credible.
Yeah, but I can see that. It's a metaphor, it's not the actual thing. So we talked about 3 different cues for technical debt. First, we discussed the most obvious, which is the social cues. And these are things like developers not wanting to deal with certain parts of the code, or frequently complaining about having to interact with part of the system. Management and developers not really being able to easily estimate amounts of effort or time required to change parts of the system. These can be social cues that there is technical debt in that area. Next, we talked about code cues for technical debt, or another term, code smells.
Yeah. And these include things like tight coupling, God objects, or objects that have too much stuff in them. Incoherence between components. So that's, 2 or more components sharing responsibility. So part of it's in one place and part of it's in another, and they vary independently. Another one is inconsistent implementation patterns, where things have changed over time and people have done it different ways, but they haven't cleaned the old out. So you never know what you're actually going to be dealing with when you go in to fix something. The next one is dead code, or undead code, as it were. That's code that isn't really called or used anywhere, or worse, where it isn't, but you really can't prove it.
Yeah, and you can't get rid of it because you can't prove that it's completely dead.
Yeah, well, a lot of people have the mindset of just pull it out and then see if anybody screams.
Well, there's that.
That becomes the eventuality. And the next one is spaghetti code. That's code that can't be followed easily from input to output. It's just where it's a tangled mess. And the final one is copy and paste code. That's where you just took code from somewhere else and plopped it in where it wasn't really needed, or where it should have been in a better place that was accessible by both components.
Or you took it from an outside source.
Just dropped it in without really understanding what it does.
Mm-hmm. And finally, we talked about testing and deployment queues. High friction in setting up deployment testing environments.
Yeah, and this kind of is almost the cargo cult thing. It's like, well, I have to do it in this particular order or bad things happen. Mm-hmm. When you hear that from a tester, that's an indication right there.
The other is frequent testing failures due to brittleness, or basically inconsistent testing failures. And then also the inability to simulate failure conditions, i.e., tight coupling of components to the point where you cannot break it.
Yeah, or you can't break it without breaking the thing that you're trying to test in the first place.
And then there's the inability to alter configuration for different deployment scenarios. And finally, the difficulty in automation of deployment scripts. And that kind of wraps us up. Before we close out, Will, what do you have for us for tricks of the trade?
Well, I'm going to go back and hit something that we've kind of hit before, and that's the Pareto principle, or the 80-20 rule.
80-20 rule, yeah.
Yeah, and it's not always 80-20, right? I mean, sometimes it's 90-10, sometimes it's 70-30, but what it tends to be is that certain things have an outsized impact. This goes to the whole life skill thing. You'll see this pattern in a lot of different environments. For instance, 10% of your user accounts make 90% of your revenue. They're the outsized accounts. And if you focus on getting more of those, it's a lot quicker to grow your business. It's basically a general principle of trying to find ways that you can have outsized effect with less effort. You'll also see this, in population studies. So like you might see a situation, and bear in mind, I'm pulling numbers out of the hat here, where 20% of the population's drinking 80% of the beer.
And that 20% of the population is
they all do podcasts on development. Let me tell you, no, not really. But you'll see this in groups of friends too, right? Like if you have a house party, there's going to be about 20% of the people that eat 80% of the food. And I'm always in that 20%, just so you know. You actually will see this sort of optimization opportunity as well in your code. Like there may be 20% of your code that's running for 80% of the execution time of your program.
Okay, yeah, I can see that.
Right, so this gives you an idea about data-driven performance as well. Like if you want to actually improve it, you need to find the code that's running most of the time. Not the code that you think is the least efficient, because you can have if you have code that's running, let's say February 29th, it can be real inefficient, because if it's running once every 4 years, that may not be the best place to optimize. Whereas something that's running continually, and this is another one of those that developers tend to hit from a technical perspective, and then they don't do it in a life perspective, right? I mean, that's why so many are unfit. Well, you can get 15, 20 minutes of exercise 2 or 3 times a week and do way better than a lot of people that will get 2 or 3 hours 2 or 3 times a week. Because if that 2 or 3 hours is, I'm going to walk on the treadmill and watch Oprah, you got some exercise, but you didn't get, you probably didn't burn as many calories as somebody that's, swinging a kettlebell for 15 minutes, or running up flights of stairs or that sort of thing. But you also have to look at the optimization, right? Because there's a certain point where that, super intense thing messes you up. But anyway, just bear this in mind, that the things that you're doing the most of are the things that you need to optimize first, are the things that have the outsized effect. And always look at things like an optimization problem.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at www.completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Thanks for listening. See you next time.